Hi, question number 6 taken from June 2015 A-Level Maths HSC Mechanics 1. Two particles P and Q have masses m kilograms and 1 minus m kilograms respectively. The particles are attached to the ends of a light inextensible string which passes over a smooth fixed pulley. P is held at rest with the string taut and both straight parts of the string vertical. P and Q are each at a height of h meters above the horizontal ground. P is released and Q moves downwards. Subsequently, Q hits the ground and comes to rest. Figure 2 shows the velocity time graph for P while Q is moving downwards or is at rest on the ground. Find the value of h. And for the second part, find the value of m and also find the tension in the string while Q is moving. Third part, the string is slack while Q is at rest on the ground. Find the total time from the instant that P is released until the string becomes taut again. Okay, for the first part we need to find the value of h. Now we must remember that h is the height. When Q travels from this point all the way down, the speed time graph will represent the speed activity of Q here, 0.5 second, 2 meters per second. So therefore the area under the graph will represent the distance here. We can say the area under the graph is a triangle, half base times height. So therefore h is equal to half times the base times the height, which is basically half times 0.5, the base is 0.5, times the height, which is 2. Therefore the 2 is going to cancel out and we have h is equal to 0.5 meters. Okay, so this is the answer to the first part of the question. For the second part, we need to find the value of m and find also the tension in the string while Q is moving. Now this is the diagram, so let us draw it again. Alright, so here we are, the pulley, and the object is released. So Q is moving downward. So therefore what is going to resist the motion is the tension in the string. So what is the mass of Q? We are told it is 1 minus m, therefore g Newton. And P has a mass of m, g Newton. Now if this is going to try to move down, the tension is going to oppose the motion. Therefore we're going to say 1 minus m g minus the tension is equal to the net force. Net force is mass times acceleration. The mass is 1 times m times the acceleration a. What is the acceleration? Acceleration is equal to the y step divided by the x step. Now we established that this is the part of the diagram that represents the motion of Q. Therefore the acceleration is y step divided by the x step. The y step is 2, x step is 0.5. So we have 2 divided by 0.5, which is then 4 meters per second squared. Therefore 1 minus m times g, and g is 10, minus t is equal to 1 minus m times 4. So we have then 10 minus 10m minus t is equal to 4 minus 4m. We can send this on the other side. We have then 10 minus t is equal to, you can send the 4 here, minus 4. Alright, so we got minus 4m plus 10m. So we got then 6m is equal to 6 minus t. So this is our first equation. Also, this is going to move upward. What is causing it to move upward? The tension in the string minus the opposing force, which is the weight itself. Therefore we're going to say then the tension minus the weight, which is mg, is equal to ma. So we have t minus g is 10, so 10m is equal to 4m. In other words, we're saying t is equal to 14m. We just need to substitute this in here. So 6 minus t, and t is 14m, is equal to 6m. So we have then 20m is equal to 6, leading to m is equal to 0.3. Here we are. Now we need to find the tension in the string. So the tension in the string is going to be 14m. So 14 times 0.3. 3 times 4 is 12. 3 times 1 is 1, plus 1 is 4. 4.2 newtons. So here we are for the second part of the question. Now for the third and final part of the question, the string is slack while Q is at rest on the ground. Find the total time from the instant that P is released until the string becomes taut again. Now let us try to see what's going on here. Okay. So this is our diagram, that's the pulley. And now the Q is on the ground, meaning that if Q is here, suppose that dP was somewhere here, it has moved. Let's call this one P is now here. Remember that the distance from here to here was 0.5 meters, and the distance was traveled. Okay, the object Q traveled this distance in a lapse of time. From the graph, this was the distance traveled under the triangle here. It took 0.5 seconds. So one part of the answer would be then that from the time P is released, let us say this was P and this is P1. So this here, it has taken 0.5 seconds. We've seen this from our diagram. What happens now when Q is on the ground? When Q is on the ground, here the object keeps on moving up, but the string is now slack, like this. Okay, so the P2 here. So this is what happens. There is no acceleration anymore. P is just freely moving upward. But there is a motion, there is an opposing force downward, the force of gravity. So we're going to come to that in a moment. But what describes the activity here? From this point to this point, this is the initial velocity and this is the final velocity. We have u and then we have v. So the object was here now. Sorry. So u is 2 meters per second and v is final velocity is minus 2. Okay, so we have u as 2 meters per second, v, the final velocity, is minus 2 meters per second. The acceleration is the force due to gravity, which is minus g. Okay, because if the object is moving upward, the force of gravity will try to pull it downward at that speed, which is basically minus 10 meters per second. Now we can use the formula v is equal to u plus at square for acceleration due to the force of gravity. So minus 2 is going to be equal to 2 plus a, and acceleration is minus 10 times t. So this can come on this side, it becomes minus 2 is equal to minus 10t. So 10t is equal to 4. T is going to be equal to 0.4. So here it takes 0.4 seconds for the object to travel from here all the way up and all the way down. So because when it comes down, the string becomes taut again. Therefore, the total time taken is going to be 0.5, this one, plus 0.4, and this is going to be then 0.9 seconds. Okay, so this is the final part of the question. Take care.